Hi, welcome you all for our next video on Module 2. It is on limit gauging system. Regarding the basic principle, gauge materials, Taylor's principles of gauge design, all these things we had discussed in the last class. That is in the last video. In today's video, we will start discussing on plug gauges or different types of gauges used for checking the system of limits or nothing but the maximum minimum limits of the components. This is a plain plug gauge, a kind of gauge which is generally used for checking the minimum limit as well as maximum limit of a hole. Always plug gauges, plain plug gauges or plug gauges are used for checking the holes. Snap gauges are used for checking the or the shafts. So all the limits for a hole and consists of two cylinders. In this we can see one is the cylinder on one end, the other cylinder which is on the other end. One indicates the go gauge, this indicates the go gauge, whereas this indicates the no go gauge kind of condition. Okay, so all the limit gauges for a holes and consists of two cylinders, two cylindrical wear resisting steel plugs whose sizes are made to the limiting values of hole dimension. So this indicates the maximum metal condition of a hole, whereas the no go gauge indicates the minimum metal condition of a hole. So the plug gauge made to a lower limit of the hole is known as go gauge, while the will obviously enter any hole with which is not smaller than the lower limit. That is what the maximum condition for a hole. Similarly, no go gauge will not enter into the maximum size. If it is if the no go gauge enters into a hole, that does mean to say that the size of the hole is greater than the maximum size of the maximum desired or specified size of the hole. This is these are the different types of plug gauges of different diameters, plain plug gauges, whereas this is a thread gauge. uh, this is a thread gauge. Okay, it is a thread plug gauge, we can call it as. Okay. Here generally over the plug gauges, at the center or over the handle they write something which indicates the nominal size of the plug gauges. Okay, and on the near to this one cylinder they write what is the maximum limit condition or the allowable diameter and minimum permissible diameter, minimum material condition, maximum permissible diameter of the hole on the other side. At the center they write they mention some diameter which indicates the nominal size of the hole. Here we can see it is written as M20, so it is meant for measuring the threads of the hole, threads or drawn or manufactured in a hole. This here the thread is of M20, that is a M20 diameter hole with a pitch of 1.5. To check or to ensure the limits of that such threads we use this this type of uh, thread plug gauges. Okay, these are all the ring gauges. Okay, this is for used for checking the external threads. Similarly, this is also a ring gauge. Different types of plug gauges I'm showing here. So that is a one thing where the one side it is a go gauge and the other side which is a no go gauge or a not go gauge. These are the two cylinders and this is a handle in between that. This type of gauges we call it as a double ended gauges. These are all double ended gauges. Here the plug gauges with upper limit is known as not go gauge or no go gauge, which I mentioned now, which will not enter into any hole which is smaller than the upper limit allowed. So go and no go plug gauges are either arranged at either end of a common handle, here which we can see in this figure or in the last photographs. On a common handle, on one side there will be a go gauge, on the other side there will be a no go gauge. So the go gauge, as we have already discussed in the earlier videos, the go gauge will indicates about the lower limit, whereas the no go gauge is meant to ensure the upper limit of the hole. So the difference, that is nothing but when the hole is making the go gauge to enter and not allowing the no go gauge to enter, it ensures that it lies within the limit. That is, the tolerance zone can be ensured with the help of go and no go gauges without checking the actual dimension of a hole or actual diameter of a hole. This is how we can analyze. So the handles of heavy plug gauges are made of any light metal alloys, while the handles of small plug gauges can be made of some non-metallic materials. Here this is a go gauge and here we can see the go gauge and no go gauges are made on two separate handles. So it means to say that these are the examples for single-ended plug gauges. That is, for a one hand over a one handle, only the go gauge is made to attach, okay, whereas the another handle, the no go gauge is made to attach. This is done when the go gauge or no go gauge are meant for checking the diameters, checking the larger diameters. That is the heavy such kind of plug gauges, we call it as a heavy plug gauges, and the handles are generally made up of a light metal alloy, so that it is very feasible to and easy for the user, while the handles of small plug gauges can be made of any some non-metallic materials. Generally, the plain plug gauges are normally double-ended for sizes up to 63 mm. If it is above 63 mm, these kind of single-ended plug gauges are being manufactured or used. For smaller through holes, a progressive form of a plug gauge is used. That is for the large holes with larger aspect ratio. In this, both go and no go gauges are on the same side, separated by a very small distance. First, the go portion is inserted into the hole. First, go gauge is inserted into the hole, and then after the full length enters into the hole, then further entry will be obstructed by the portion if no go gauge of the hole is within the tolerance limit. If the tolerance limit, that is the maximum size of the hole, is greater than the no go gauge, even the no go gauge will enter. In that case, the hole size is larger. Such holes are rejected, correct? So that's how the tolerance limits are being ensured. The go gauge will pass through the minimum size of the hole, and it will enter till the no go gauge get in contact with the entry of the hole. When the no go gauge will try to enter into the hole, it is being restricted or obstructed, so that, yeah, the tolerance limit is being further confirmed, and both are done on a single handle, but it is in a progressive form. That is, initially the no go gauge, after that there is a no go gauge. So this kind of gauges, we call it as a progressive form of plug gauges. If the dimensions of the hole are above the 100 mm and up to 250 mm, a shell form of plug gauges are used, because the whole plug gauge end or the cylinder will become very heavy when the size of the hole is greater than, to be ensured, is greater than 100 mm up to 250 mm. So in that case, very large holes, spherically ended gauges are used with making the shell form of gauges. So the at the center of the plug gauges, the material is removed, that makes the whole plug gauge as a lighter. So the design of this go gauge and not go gauge will be bit different compared to the other types of gauges here. Here we can see the shell form with if we can see on one side, it can be it looks like a I section. So this is a kind of shell form of plug gauges. One handle, and at the end of the go gauge, or on the other separate handle, and no go gauge. So go and no go gauges are maintained on a different handles. Next is about the ring gauges. They are used to check the dimensions of the shafts, which we have seen in the previous slide. The ring gauges, they are used to check the dimensions of the shaft. They are limit gauges for gauging the shafts and are used in a similar smiley manner to that of go and no go plug gauges. A ring gauge generally consists of a piece of metal in which the whole So a ring gauge consists of a piece of metal in which a hole of the required size is being bored. There are in the forms of a ring made with wear resistant and hardened steel to about 720 HV. If we are saying in terms of Rockwell hardness, it is obviously more than 60 HRC, because the 60 HRC and above will when the metal possesses more than the 60 HRC, it possesses a very good hardness and a highly wear resistant material. That's why generally all the ring gauges or plug gauges, they are made with the steels and they are hardened to a very high hardness up to 60 and above HRC. Here the ring, as we have seen in the ring gauges also, either it can be a thread gauges or a plain ring gauges to check the diameter of the shaft. This is one example for the ring gauges. Here we can see the similar diagram we have or figures we have seen earlier also. Here we can see in this especially in this uh, gauge, here it is written as 28 mm. That is the nominal size of the diameter, nominal size or nominal diameter of the shaft is 28 mm, and it is to be checked at the 20 degrees Celsius. Okay, and similarly the tolerance zone which is written and yeah, whether it is a go gauge or no go gauge, everything is will be written on this ring gauges. Next is about the snap gauges. A snap gauge, again, it is also a type of gauge which is used to check the tolerance zone of a shaft. A snap gauge usually consists of a plate or a frame with a parallel faced gap of a required dimensions. In these gauges, the gauging anvils can be adjusted endwise to suit any particular limit dimension required. Snap gauges, they are used for both cylindrical as well as non-cylindrical work, as compared to ring gauges which are conventionally used only for cylindrical work. Ring gauge, that means to say, like ring gauges which we have seen in the last slide, it is ring gauges are specially meant for checking the tolerance zone of only cylinders, whereas the snap gauges, they can be used to check the tolerance zone even for the non-cylindrical workpieces also. That is the major advantage of snap gauges over the ring gauges. Even they are also called as gap gauges for the same reason. And then double-ended snap gauges can be used for ranging from 300 to 3 mm to 100 mm diameter. Similar to plug gauges, here also double-ended snap gauges are available. Even the double-ended snap gauges, progressive type of snap gauges are also available for checking the tolerance zone of nominal size diameter of 100 to 250 mm diameters. So this is a go gauge or go gap for a double-ended type snap gauge. Here we can see one side it is made as a snap go gauge, and other side it is made as a no go gap gauges or snap gauges. The gap here between the two anvils, the gap between or the distance between the two anvils of the snap gauges indicates the diameter of maximum diameter and the minimum diameter of the minimum permissible diameter of the shaft. Similarly, this is a progressive type of a snap gauge. The initial one, it indicates the go type of a snap gauge, whereas the second one indicates the no go type of a snap gauges. That is the maximum permissible diameter and minimum permissible diameter of the shafts. So this is about the different types of gauges that is for used for checking the tolerance zone of shaft and the holes. Okay, so this completes the another part of this module 2. Now, first one in the first phase, we have learned in the module 2 about what is limits, what is tolerance, and what are the different tolerance grade and limit sizes, standard tolerance grades. All those things we have learned. After that, we have learned about the different types of gauges to check or ensure the tolerance zone of a given diameter of a shaft and the hole. Okay, so that is about the gauges. In the next video we will discuss about the comparators, different types of comparators and amplification devices, especially these comparators are also devices which are used to uh, compare the two elements. One is being the standard and another one is being the non-standard element or object or physical quantity. In measuring instruments we exactly measure what is its actual dimensions. So all measuring instruments are generally comparators, because there also we are comparing the standard scale with the unknown physical quantity. That is what the measuring device. From a simple scale to a complex instrument, all are comparators. Do remember, but at the same time, all comparators are not measuring instruments, because a comparator works on a relative measurement. It gives only a dimensional differences in relation to the basic dimension. Okay, in measuring instruments, or though it serves the same purpose, but there we actually come to know what is the actual dimensions. But here in general a comparator just gives the relative measurement, that is it is going to yield the dimensional differences in relation to the basic dimensions. All comparators, irrespective of their type, usually consist of three basic features. First one is a sensing device, second one is a magnifying or amplification device, and the third one is the terminating device or a display system. A sensing device which faithfully senses the input signal, that is nothing but through a device we are giving some input, and in a magnifying device the signals are being amplified. Example, for a speaker, let me take with a simple example of a speaker. To a speaker a sound signal is being sent. Okay, the signal which is sent in terms of electrical signals, that is actually input signal, whereas the amplification is being done and the conversion of after the amplification is being done with the help of amplification devices, and then finally a display system or output system is going to come out, that is the as again output as a sound. So it is another way of taking it as a whole system. That is when we are going for a particular application like a speakers. When we go restrict ourselves to the measuring instrument, let us go with a ammeter or a dial gauge, in which if I am taking the example of a dial gauge, as plunger is coming out of the this dial indicator. When the plunger is being pressed, that is the displacement, if what we are going to the giving to the plunger, that is the input signal, and that is being amplified with the help of a spring which is behind this dial indicator scale, that amplifies that signal, which is nothing but the displacement of the plunger. It amplifies and converts and gives output as a movement of the dial in a dial indicator. The dial indicator is a display system. That is how the whole system of comparator works. So dial indicator is also a kind of, or it is an example of comparators. So why the comparators are required? Though there are many measuring instruments, why the comparator is required? It is it is required in mass production especially, and mass production would be impossible if the components could not be produced to close dimensional tolerance. That's why comparators are required. Wherever the dimensions must be checked with high degree of precision and speed in the production, mass production. Examples like a piston. And in when many dimensions are to be checked simultaneously in a or to be checked in a very short span of time. For inspecting newly purchased gauges, even for that comparators are necessary, because we need to calibrate the newly purchased comparators. So classification of comparators. The different types of comparators is, one is mechanical comparator, second one is mechanical optical comparators, third one mechanical electrical and electronics comparators, fourth one pneumatic comparators, fluid displacement comparator, projection comparators, multi-check comparators, automatic gauging machines. These are different types of comparators. What are the characteristics of such comparators? Robust design and construction is the first important characteristic of a comparator. Second one is readings are obtained in the least possible time. The comparator should be designed and it should be facilitate the operator to give the readings in the least possible time. Because we can measure the comfortably the actual dimensions with the help of measuring instruments, but in comparators we expect that it should be able to give the relative display relative difference in the readings within the least possible time. They should be free from backlash errors. The wear effects and inertia should be very minimum. Compensation for temperature effects need to be done. Scale must be linear. Indicator should be constant in it return to zero. Where it should be highly very sensitive. uh, it should be maximum, it should possess maximum versatility, and measuring pressure should be low and constant. These are the important characteristics of a comparators. That is, first is about the design should be design and construction should be very good enough, so and it should be robust. Readings, as we discussed, it should be able to give the difference in relative readings in a minimum possible time. Backlash errors, it is always expected in all kind of measuring instruments. The backlash errors should be as minimum as possible. Wear effects and inertia should be minimum because it is a common phenomena when we are going for mechanical type of comparators. Compensation for temperature effects, like when there is a change in the temperature, that should not cause the change in the readings, that should not impart errors in the readings. The scale should be as much as possible, it should be linear, so that the operator can understand the readings easily. Indicator should be constant in its return. That is, once the loading of the component is being removed, that is, once the unloading is done, then it should return back to the zero reading. That is nothing but every time it should not have any kind of a hysteresis loss. That is, it should completely come back to zero reading. Next is about a very sensitive. A very small variation in the input signal need to be sensed and precisely, and then give a very accurate output signals. That is another important desired characteristics of a comparator. Next is about maximum versatility, and measuring pressure should be as low as and it should be constant, or else the damage of the components may or measuring instruments may occur. So mechanical comparators, will discuss about the mechanical comparator in the next video. Okay, thank you. Thank you for all for your patience listening. I have used many textbooks, resources, as well as many internet resources for preparing this teaching material. I acknowledge all such resources here. Thank you for all.